Well,
Okay, continue.
The roots are the x values when y is 0, right?
Okay.
I learned maybe like the roots are like when you set the factors equal to 0.
Okay. Anybody else? Anybody wants to say, sir, I'm thinking, but I'm not so sure. Anybody wants to say, sir, I forgot. I learned it, but I forgot. Anybody wants to say, sir, I have no clue. All good comments for me, but tell something. Akanksha, have you spoken? Ananya? Okay. Let's see that these three terms when we talk about quadratic equation. First of all, let's try to identify if you have y equals to 2x minus 3 and you have y equals to 2x square minus 5. Which of them is a quadratic equation?
The second one.
Why it's a quadratic equation?
Because the exponent needs to be 2.
Okay. Anybody else?
Because when you graph it, it needs to be a parabola.
Okay, very good comment. Yes, others, please. Why is 2 a quadratic equation? A very good answer is x has a power of 2. But I think about it. If y also has a power of 2, then what will happen? Will it remain a quadratic equation? No, it will not, right? Am I right? It will become something else. In quadratic equation, either the power of x is 2 or y power is 2, but not both. Because if both have x square and y square as 2 powers, then it will probably become circle or some other graph. It will not remain a quadratic equation. Okay, quadratic means 2. Okay, power is 2. So here the power is 2. Okay, and it is a quadratic equation. Now, all quadratic equation tends to take the shape of a parabola. How many of you are hearing the word parabola for the first time? Anybody? Anybody who hasn't heard about parabola at all? Okay. Now, how does parabola look like? Let's say this is your x and y graphs. This is x, this is y. Okay. Parabola will be like this, like this, like this, like this, maybe like this, this. But essentially, all these shapes that are going here and there, okay, are taking an expanded V shape. It can be right, left, corner, whatever it is, but they are all taking an expanded V shape. Okay, expanded in the sense it is coming like this and then going like this. This is how the shape of the parabola is. But now this parabola can be like this, wherever you want to put. Okay, so if you want to graph this is going to be the graph, but it can be in a different areas based on the values. It can be on this particular side, like tilted like this, depending on the equation. Are we clear so far? Are we following that? Anybody who is not following?
I'm following.
Following. Anvi, Srinidhi, Santosh, Meenakshi,
Yes.
I'm following.
Johans, Sanjo, you're following it, right?
Yeah.
Okay. Now, let's take a typical example. I'll take an example as x square minus 9x, okay, minus 10 equals to 0. Can I call it that this is the quadratic equation?
Yes, sir.
Yes.
Everybody agrees this is a quadratic equation?
Yes.
Okay. This is a quadratic equation. What is the difference between this and this? There is a y here, there is no y here, right?
Yeah.
So I can say this is equals to y equals to this. I can say y equals to this, y equals to this. Now this and this look similar, something like that.
Yeah.
Right? This looks similar. Okay. Now, in this particular scenario, we are going to make y as 0. Okay. From there, the quadratic concept starts. We are going to make it as 0. Means the y value I am dealing with in quadratic equation has to be 0. So you make this as 0. Okay. If 0 equals to this, that means you can also write this 0 on the other side, which is equals to 0, right? Now did it become a quadratic equation?
Yes, sir.
Yes.
How many of you learned factoring before?
I
I
did.
did so.
I did.
I did.
How many of you don't know about factoring? Anyone? Guys, I want you to be very, very confident in saying that, yes, sir, I don't know. As I told you before, you don't have to go by your friends who are there in this group. You should be like, I am learning with Kamal sir, and if I have any problem, I can ask. Even a slightest doubt, you can ask. You can also say, sir, I've learned it, but I forgot. And also say that, sir, I'm kind of like less confident, but I know what is factoring. Okay. Now, how many of you think that, say, sir, I think I can do the factoring for this one?
I do.
I can do it.
I can do it.
Okay. Now, I am not going to discuss how it should be factored for now. That factoring, you must have learned in 6th grade, 7th grade. Okay. It's not that I don't want to teach you that. It's not like that, but it's like it needs some practice before you say that I can really do that. It needs some practice, some level of practice. Okay. So what I'm going to do is I'm going to directly write the result of this. Okay. After you do the factoring, you are probably going to get this as x minus x square minus x minus 1 and x plus 10.
I got x minus 10 and x plus 1.
Okay. X minus 10 and x plus 1. Does it sound about right? About right. I'm not
Yes.
solving it. This looks okay.
Yes.
I think the factoring's done right.
Factoring. So, guys, again, I tell you, I have not gone through the steps. I directly wrote the results. Now, what we need to understand is these 3 terms. Factors means from here I will start explaining what is factors. Factors means this x minus 10 and x plus 1 are the factors. Okay. These are the factors. Factor number 1 is this, factor number 2 is this. Roots are when x minus 10 you make it 0 and x plus 1 you make it 0. So this becomes x is equals to 10 and x is equals to minus 1. These are your roots. Are we clear? So far we
Yes.
are following, guys.
Yes.
Solutions and roots are similar things. They are just synonyms. Okay. But when somebody calls you what are the solution, it technically means technically means where is the graph intersecting the x-axis, which means somewhere the graph will be intersecting at 10, okay, and -1 here, which means the graph could be like this. It could be like this. It could be like this, anything. But if you draw this one, okay, this particular quadratic equation, it will take this parabola shape, which will intersect the x-axis definitely at -1 and 10, because you found the roots like this. And solution says, where is the graph intersecting the x-axis? It is -1 and 10. So the solutions for this graph is -1 and 10. So there is no difference between roots and solutions, but the answer, the way you would say, is different. Solution means wherever the graph is intersecting at x-axis. You are getting the same result, 10 and -1. And when somebody asks you, what is the root? When I take the factors and make it 0, then the values I get are called the roots. Answer will be same in both the cases. Only the thing is, you are thinking or you are heading in a different directions, but the answer will remain same. Are we clear about this?
Yes.
Do we understand factors, roots, and solution?
Yes.
Yes.
Okay. How many of you are clear, guys? That yes, sir, we are clear on the so far.
I'm clear so far, sir.
Anybody who is not clear so far?
Clear so far.
Okay. Others, please. Srinidhi, your hands.
I'm
Still
clear.
waiting. You are clear. Okay. Okay. Now, let's try to move ahead. What is the next thing that you should learn about quadratic equation? Factoring is one method of finding roots. Are we clear? What is factoring? Yeah. Factoring, you got till here is the factoring. But what does factoring gives you? Factoring gives you a way to find roots. If you do not have these two factors, you cannot equate back the roots and you cannot find the roots, right? So factoring is a way to find roots, right? Can I say that? No? Yes or no?
Yes.
Yes.
Yes, sir.
Okay. So there is another way of directly finding the roots by using formula. That formula is x is equals to minus b plus minus b square minus 4ac by 2a. Okay. How many of you heard about this formula, please?
I did.
I
I
know
heard of it.
formula, sir.
How many of you haven't heard about this formula, please? Everybody has heard about this formula. It's strange. Okay. But you have to also understand, to find this, you have to understand that this is applicable to a generic equation, which is ax square plus bx plus c equals to 0. When this is the equation, this is the formula. So if your equation is x square minus 9x minus 10 equals to 0, the value for a is here, value for b is here, and value for c is here. you have to put that in this formula and you will directly get the roots. Now I want to ask you guys, have you guys just known this formula or you have played around this formula? That yes, sir, we have.
I
Mm.
use this
Yeah,
formula.
I've used this.
I've used this before.
How many of you are not sure of using this formula properly?
I don't.
Okay. Others? Anvi, Ananya.
I've used it.
Okay. How about you, Anvi?
I've used it.
Sure how to make the use of it?
Yes.
Okay. Yes, Anvi, Akanksha. Akanksha, you know this?
What? I said I used it, so.
So, Anvi, Akanksha, can you guys help me to find the roots of those of that above quadratic equation using this formula? What should I do here?
You should plug in -9 for b. I mean, it becomes a positive 9 when it's minus b, plus or minus. And then substitute -9 squared, minus 4 times 1 times -10, whole by 2 times 1.
How many of you think that she is right?
I do.
How
Yeah.
many of you are not clear on how the values were substituted? How many of you want me to explain how the values were substituted?
Can you explain?
Yes, Sanjo, sure. So, when you compare this generic equation with this particular equation, do you see that A here is equals to 1, B equals to -9, and C equals to -10, Sanjo? Compare it with this and this. A, there is nothing here, so this is 1.
Mhm.
B is -9. C is equals to -10. Are we sure? Are we okay?
Yeah.
Okay. We have just taken these values and put that in the actual formula. Are we clear?
Okay. Thank you.
Yes.
Yes.
Understand.
Clear. Okay. Yeah. Totally clear.
Yes, sir.
Okay. This will give you +9 and plus minus. This is -9 whole square, 81.
Yes.
81 negative into negative become positive. 81 plus 40 by 2. This becomes +9 plus minus 81 plus 40 is what? 81 plus 40 is 121.
Yes.
Square root of 121 is what?
11.
11. So this is 11 by 2. Okay. Now what I'm going to do is I'm going to break this into two parts. One is going to be +9 and then I will pick the +11 part and by 2. Another part is +9 and the negative part which is -11 and 2. So note the difference. Here is negative and here is positive. This become 11 plus 9 which is 20 by 2 equals to 10. 9 minus 11 is -2. -2 by 2 equals to -2. See, you have got the same roots of what we have here. Are we getting it so far?
Yes.
So
Now, what is the important thing we learned? Important thing we learned is we all mentioned that factoring is a way of finding roots. Okay. I don't like factoring at all because this is complicated. But I want to get the roots. Good. No problem. I will take this equation, put this in the formula. I am directly getting the roots. No need of factoring. Are we clear?
Yes.
or not clear? So here I am still getting to know the roots without doing the factoring. Why? Because I have a direct formula to find the roots. Are we clear? Meenakshi,
Yes.
Yes.
Srinidhi,
Yes.
are you clear, Srinidhi?
Yes.
Okay. Santosh,
That's clear.
clear, half clear, 70% clear, 100% clear. Santosh,
Fully clear.
fully clear? Very good. Sai,
I'm clear.
how much? 100%, 20%, 50%, or 70%?
100%.
Oh, very good. Okay. So far we all followed, right? So factors, we are clear. Roots, we are clear. Solutions means wherever the graph is intersecting at to the y-axis, right? But guys, here there is one thing that I didn't tell you, right? Parabola may not touch the x-axis. Is it possible?
Yes.
Possible?
Maybe like when you don't have a solution.
Well, the parabola may not have a solution. How is it possible? These are the things that we haven't discussed, right? Nobody asked me also. That, sir, parabola can be here, you draw here also. In this particular parabola shape, it is not intersecting the axis, then what will happen? Am I question correct?
Yes.
Yes. Am I asking the right question? Right or no?
Yes.
I'm asking the right question. Okay, fine. If I'm asking the right question, there should be some answer to that. For example, let's understand this. If you have this x and y axis, if the parabola goes like this, you have 2 points of intersection, right? This and this. So you'll have two solutions. Yes or no?
Yes.
If the parabola is going like this, you have again two solutions.
Yes.
But if the parabola is going like this, it is not intersecting anywhere. That means there is no solution.
Yes.
Okay. But there is also one more scenario. If the parabola touches the x-axis and go, then touches
It
the
has one
x-axis.
solution.
It has one solution.
Yes, sir.
Complicated, right? How can it has one solution? How can a quadratic equation have no solution?
It has two.
Okay, it has to be two, right? Okay.
Yep.
Are we clear on the doubt here? Ask yourself and tell me that, sir, yes, at least I understood what you are trying to say. There's some doubt here, right? Parabola can take any shape. Parabola can be like this, like go like something like this. It is going up, or it may be going down like this, but without touching the x-axis. Is there any solution for that? I would say no, there is no solution. If there is no solution, then there are no roots. Okay. Parabola, if it intersects 2 points, then we say there are two values, there are two roots. Perfect. If it touches, then we said, okay, there is one value. But a quadratic equation, how can it has one value or no solution? Is it possible?
Sir, I think it's possible to have one solution because when it's like x plus some number and squared, basically you're going to get same number even if you solve it.
Okay. Others,
Mm.
please, whoever has learned about quadratic equation, please try that.
It's also possible to get no solutions because sometimes, like when you do the quadratic equation, under the square root, you end up with like a negative number.
I'll come to you, Meenakshi. Thank you. Anvi, Anaya, what is your thought? What did we understand so far? Yes, Anvi. Anvi, I'm not able to hear you. Anybody who can hear Anvi? Anybody able to hear Anvi? I feel there's an audio problem at my end or Anvi's end. Anvi, please be a little loud.
Can you hear me?
Yes, Anvi, I can hear you now.
Okay. I was saying I don't think it's possible to have any more or less than 2 solutions because that's what it equals. Unless you're writing it with the plus or minus sign, I don't think you can get one solution or more than 2.
Okay. Thank you, Anvi. Ishan.
Yes, sir.
Yes, sir, please.
You can't get one solution because it's just sort of written like that because the plus or minus sign kind of does not allow, like, you can't have one solution unless like you know it's a negative, then maybe.
Okay. Not very.
You can.
Yes, I
think you can have one solution because if there's a 0 under the square root, there would only be one solution.
Okay. Who hasn't spoken? Shantosh. How about yours?
I think one solution and zero solution is possible, but you would have imaginary roots if you were to have.
Okay. Srinidhi.
I think you can have one solution because sometimes you get two solutions, but if you put it back into the formula, it doesn't work.
Are you sure, Srinidhi? Doubtful.
Yeah.
Johannes.
Yeah, I think you can get 2 solutions. I mean, 0 solutions or 1 solution.
How? Is it possible? How?
If the starting point is different.
Okay, starting point is different, but algebraically, you have to understand how that can correlate. So let's take an example. If you have x square minus 12x plus 36 equals to 0. Okay, this is the quadratic equation given to you. And you want to solve this to get the roots. Okay. Now, if you try to factor it, okay, you will be doing steps like this. X square minus 6x plus 36 is equals to 0. What I have done is minus 12x has been broken into minus 6x and minus 6x. It's the same thing. I am going to make this and this 2 different expressions. I am going to take out x common from these, so I'll become x minus 6, and then another minus 6 common, it will become x minus 6 equals to 0. Okay. Now, with these 2 expressions, okay, I'm going to take out this x minus 6 again. If I take out x minus 6 back again, I'll be left with this x here and this minus 6 again. So you see that the 2 terminologies are same here. Okay. When the 2 terminologies are same, this becomes x minus 6 whole square equals to 0. which gives something whole square equals to 0 means the same statement equals to 0 and x is equals to 6. So in this particular scenario, you are only getting one root. Because when you are factoring, finally you are landing in the same term. If you are landing in the same term, this becomes a whole square. It's not the scenario like x minus 10 and x plus 1. It is a scenario where the factors become same. When the factors are same, the root will have one value. Okay? Because the expression itself became a perfect square. This expression is actually becoming a perfect square on its own. And in that scenario, there'll be one root. And if you draw this graph on x and y axis, it will be some graph that are going to touch the x-axis and leave. This, in this particular scenario, x is equals to 6 means the graph will be either somewhat here or somewhat here, whatever. But it will touch x is equals to 6. That's it. And that is the value. Are we clear?
Yes.
Yes.
Yes, sir.
Now, in a scenario where it does not touch the x-axis, there are solutions. Definitely there are solutions. In this particular scenario, okay, there are solutions, okay? But those solutions are not real solutions. This particular graph, there are solutions, but they are not real solution. That means what? Means if a parabola is not intersecting the x-axis at all, then the roots or the solutions are not real values, they are imaginary values. How are the imaginary values? Imaginary value is something like negative of 3 square root, negative of 2 square root. These are imaginary values. So definitely there will be values, there will be roots, there will be factors, everything is okay. But in this particular scenario, all these will be non-real, they will be all imaginary. So the roots will be imaginary. So there are three categories of roots that we have to understand. First is if the parabola is intersecting twice, which is the maximum it can do. If the parabola is intersecting at two different points on the x-axis, we get two distinct real roots. Two distinct real roots. Just like in this case, minus 10 and 1, finally we got 10 and minus 1. If the parabola is touching the x-axis, just touching, root will be 1, and when you solve it, it will become a perfect square. And when it becomes a perfect square, you just get one root. And in that case, that parabola will just touch the x-axis, but will not intersect at two different points. Third category is the parabola do not touch or intersect the x-axis. In that case, there will be roots, there will be factors, everything will work, but they will be imaginary roots like these. These are imaginary roots. Are we clear?
Yes.
Yes.
Are we
Yes.
clear about this quadratic equation concept? Anybody has any doubts
sir.
so far? Sai, Ishan,
No, I don't have.
Santosh.
No, I don't have many doubts.
Even if you have one, you can ask. Anvi, Akanksha,
I'm clear, sir.
Johans,
I'm clear.
Srinidhi.
I'm clear.
Okay. So we have come to know so far what are the factors, root, solution, and types of roots. Okay, we are clear on that. Okay. Now another thing that we have to be clear on is this component. Okay. This is called discriminant. In your book, if you find it out, discriminant, it will say this is discriminant. Okay. This discriminant defines what kind of roots a quadratic equation will have. Because this is the guy who is taking all your decisions. Whether it has two distinct roots, whether it has imaginary roots, or whether it has one root. Three distinct types. So I will make a clear rule out of this discriminant. Okay. How will I make that rule? That rule would be, first is, if b square minus 4ac, which is the discriminant, is greater than 0, two roots. Number two, if b square minus 4ac equals to 0, one root. Number three, if b square minus 4ac is less than 0, imaginary roots. These are the three classifications. I know I've messed up over here, but let me probably just remove this. Okay, now you can ask me, sir, why are we having a correlation like that? I'm not clear. Somebody who's not clear, guys? Why I'm saying so? That discriminant defines your type of roots itself. How far are you clear? If b square minus 4ac is greater than 0, you see this will be a real time value. And these does not define anything. Minus b, 2a, whatever it is, they are okay. But this has to be greater than 0 for two distinct roots. That is why I said if b square minus 4ac is greater than 0, there will be two distinct roots. Second is, if b square minus 4 equals to 0, then this portion goes away. So as this plus and minus, there is no plus and minus here. Then only minus b by 2a, which is one value. If your plus and minus become this component 0, then there is only b minus b by 2a. Minus b by 2a is what? Minus b by 2a is one value. You cannot have plus and minus. This plus and minus component is gone. So it will have one root. And this goes negative. B square minus 4ac is negative. Then the square root becomes a negative term. And as soon as it becomes negative, they will take imaginary roots. Imaginary roots in that situation, the parabola do not touch the x-axis. How far are we clear?
Clear.
How far are we clear? Yes. Is that too much of information for today? Somebody wants to say, sir, too much now. I cannot. My brain is exhausted already. Please stop it. Anybody wants to say that? You can say, sir, we are done. I didn't have my tea since the morning. Anybody? Somebody feels this is more than enough for today? No? We should have more, continue more? Anybody wants to say it was a good revision at least? I learned all these things earlier, but I didn't know, was not so sure.
This was like a good, like, refresh to my mind.
Yeah, it was a good reason.
Yes, yeah, I agree.
Okay. Anybody else? Others are quiet. Somebody must have learned something. Maybe you wasted your time. You can say, sir, I wasted my time. I was knowing everything. Yes. Srinidhi, Johannes, Sanjo. Quiet. Yes, Sanjo. Sanjo, you have any comment? No comments?
This one.
What happened, Sanjo? Johannes, what about you?
It was good.
Ishan already said. Ananya,
I'm good.
okay. Anvi, yes, I didn't hear about that.
I said I think this was a good refresh.
Okay, thank you. Okay, guys. So today I want to keep this theory as it is. I would recommend please take a snapshot of the board, because in the next class we are going to discuss some practical problems related to this, some numerical problems. But we have to keep this theory in mind. Please take a snapshot, keep it with yourself for reference, and come up with some revision in the next session, okay, which is going to be on Wednesday. Please take a snapshot and enjoy the rest of your day, guys. I'm leaving you a little bit early. I feel like this is too much for your intake today. Okay, so I'm leaving a bit early today. Okay, please feel free to log off. If anybody has any questions, please stay back, or else please log off. I will talk to you again on Wednesday. Thank you so much.
Thank you.
I have no.
Thank you. Bye.
Thanks for the class.
Thank you.
Thank you.
Thank you, guys.
I had a question on the flexi quiz like homework thing.
Yes.
And it's kind of related to today's class, I think. Should I tell
Okay.
you it out loud or?
Yes, you can tell me now.
Okay, so the